We are now going to talk about how we calculate the motions of stars. We've already done some of this, so some of this is going to be a review. There are a number of different formulas that we're going to use, depending upon exactly what we're going to try to calculate. One thing we are going to have to do is make sure that we have distance in parsecs. So let's remind ourselves of how to convert from light years if a problem is given in light years. Another thing we're going to have to do is remember the Doppler formula. The Doppler formula is going to be important for giving us the radial velocity. We're also going to have to remember how to find distance from parallax. The two new formulas that we're going to be using here are the formula for VT, known as transverse or tangential velocity, and the formula for the space velocity, which is nothing more than the Pythagorean theorem. So what are the big ideas here? The first big idea is that we find the distance from the parallax. If you don't remember how to do that, see a previous PowerPoint. The second big idea is that we find the tangential or transverse velocity VT from the distance that we've gotten from the parallax. The third big idea is that we need to get the radial velocity VR from the Doppler effect. If you don't remember how to use the Doppler formula, please go back and see a previous PowerPoint. Once we have the VT and the VR, then we can find the space velocity Vs from Pythagoras' theorem. Vs squared equals VR squared plus Vt squared, where Vs is in kilometers per second. Vt and VR are also in kilometers per second. So how do we find Vt? Well, the formula for Vt is given on the slide. And notice that it already says that you're going to get the answer out in kilometers per second. So there are three parts here. The first is a number, 4.74. This number takes care of all the unit conversions that we need to do to get to kilometers per second. Isn't that handy? The second piece is this funny looking Greek letter mu. Mu is something called the proper motion. It's how fast the star appears to move relative to other stars in the sky, and it is given in units of seconds of arc per year. The third piece that we need is the distance, and notice that once again the distance must be given in parsecs. So let's do a problem. If the distance to a star is 13 parsecs and its proper motion is 0.1 seconds of arc per year, what is its tangential velocity? Well, we have the formula, but before we grab the calculator, let's do a units check. Now, is the proper motion given in seconds of arc per year? Sure is. Is the distance given in parsecs? Yep. All right, now we're ready to go. So we plug in 4.74 times 0.1 times 13, and it gives us 6.2, and the formula already tells us that the answer is going to be in kilometers per second. So now that we have Vt, if we're given Vr, we can find the space velocity of the star. So what is the space velocity of the star if its radial velocity, again found through the Doppler effect, is 12 kilometers per second? So we have the formula for Vs squared. Again, it is the Pythagoras' theorem or the Pythagorean theorem. Vs squared is Vr squared plus Vt squared. All of these are in kilometers per second. So Vr is given to us in the problem, 12 kilometers per second, and we're going to have to square that. And then Vt, we just calculated, is 6.2 kilometers per second, and we're going to have to square that and then add the two of them together. So we end up with 144 plus 38 equals 182. But look what's happened to the units. When we square these, we end up with units of kilometers per second squared, kilometers per second squared, and kilometers per second squared. This is to remind us that we are not done with the problem. We need to solve for Vs by itself, but we're given Vs squared in the formula. To undo Vs squared, we need to take the square root of both sides. So if we take the square root of the left-hand side, we undo the square and we get Vs by itself. if we take the square root of 182 kilometers per second squared, we undo the kilometers per second squared, gives us just kilometers per second. The square root of 182 is 13.5, so the space velocity is 13.5 kilometers per second. This last step is something that students often forget. So please do not forget to do this last part of the problem. Take the square root and get the space velocity by itself.